Okay, let's start. Good morning or good evening to all, and welcome to the Data-Driven Community Virtual Meeting. My name is Ronen Arieli, and I'm honored to host this meeting today. The Data-Driven Community manages two branches. The first one is a weekly meeting of the Cloud Data-Driven User Group, like today. And the second one is an annual conference called Future Data Driven Summit. At our next user group meetings on June 1st, we will host Matt Gordon, and we will discuss how to power up your tech career with Power Apps. The Future Data Driven Summit 2023 will be held on September 27. The call for speakers will be closed in about a week, a bit before, and we will start to select the best of the best sessions for the conference. You are welcome to register as participate, and if you have a session that you want to speak, you still have a few days to submit it. Today we are hosting Ed Pollack. Ed is a data architect and Microsoft Data Platform MVP. He is speaking all over the world at multiple conferences and user groups. And in fact, Ed is one of the leaders of our community and a co-organizer of the Future Data Driven Summit. So Ed, you are welcome to share your screen and take control.
All right. Thank you very much. I will say, right away that I have a great appreciation for online training. I think many of us kind of got tired of it after 2020 and everything being virtual. But now we're in this weird period where in-person events exist, but they're not quite as big as they used to be. And virtual events exist. There's a great place in the world for both. So I'm very appreciative of the fact that we have this and it continues to happen so frequently. So thanks for having me. And I will dive right on in. This session is all about new stuff, not quite as new as it was 6 months ago, but new features. New T-SQL and SQL Server 2022. I focus on this and have a whole session about it because very often the T-SQL gets brushed under the rug. We get really attracted to shiny new features. We see things in Synapse or the brand new Fabric or anything new that comes out, AI, and we jump all over it until we've jumped all over as much as we can. But there are core features that affect data everywhere, no matter what, and SQL Server and T-SQL are that. And so this whole session is about new T-SQL. It's been around now for about 6-7 months since 2022 came to market. It was before that in previews. So this has all been tested in most current version of 2022. So it should work for you as well if you're using 2022. And we're going to talk about how to make code better, faster, and easier to use with new features. This is me. I'm a data platform MVP. I've already been introduced, so I'm not going to introduce myself any further. Here's some of the things that I'm working on. I'll have my info at the end of the session in case you want to contact me afterwards. Feel free to do so with questions, comments, thoughts, whatever. As well, if you have questions during the session, you can put them in the chat and maybe Ronan will grab them, or we can just have Q&A at the end. Whatever is easiest for you is fine by me. The agenda is straightforward. I'm going to intro a whole bunch of the new features, not quite every single one, but most of them, the ones that I like the most. So my favorite features, not all the features, but they're my favorites. And then a lot of details about compatibility levels and versions and all that, and jump through just lots of demos. I feel like in this case, demos are helpful. They really show how things work, what they look like, and where we're going in terms of data. And then we'll wrap up at the end, take questions, tell jokes, do whatever we're going to do, and then off we go on to the rest of our day. A key to really any platform like this.
Just before you start, I want to remind everyone, please use the chat for questions, but not only questions, feel free to use it for discussions. If you want to respond to someone else, that's okay. And I also put the two links for the next week event and the Future Data Driven Summit.
All right. Feel free to chat in the chat. I'm not watching the chat, but I'm sure it's wonderful and it's there, so please enjoy it. This session is all about new features. Every new version of SQL Server has new features. Those features include new T-SQL functions and changes and enhancements and improvements. Some minor releases have it too. And it doesn't really matter where you have your SQL Server servers. They could be on premises, they could be in managed instance, they could be somewhere in Azure. It doesn't really matter where they are. Compatibility level and new features apply to them. The main difference is that if you're on premises, you decide when you put the new version there and get the new features. If you're in Azure, that comes to you when the time is right. So either way, though, everything in this presentation affects you regardless of where your data lives. And the big gatekeeper for all this, mainly performance, is compatibility level. This is something that since 2016 has been guaranteed. Therefore, if you set your database into a specific compatibility level, that compatibility level will gatekeep the performance of SQL Server at that version. It's meant to impact behavior primarily and not features. Not all features are available for a certain compatibility level, but SQL Server tries to include as many as possible, and that's very important. The point of the compatibility level is to really facilitate smooth upgrades. You're upgrading from one version to the next, and you want to be sure that things are going to behave the way you expect them to. You could jump right to the new compatibility level if you want, or you can keep it the old one, wait and see, and then up it when you're ready. If you're doing a major upgrade of many versions, if you're taking something on 2012 and throwing it into Azure, if you're going many versions at one time, keeping compatibility levels and then moving up over time could be a great way to kind of mitigate risk. And of course, some features in general are Azure only or on-prem only if they're relevant. If you're using a managed instance and you care about the operating system, well, you don't have access to the operating system. So any features or views that affect that, you won't be able to see them. Likewise, on-prem, there are a whole bunch of views and features missing because they're Azure only. So just the feature isn't there, the enhancement's not there, but that won't really be a major part of the discussion today. Real quick, I'm going to jump into a demo. We can all see SQL Server Management Studio here, hopefully. Great. We will dive right on in. And I have my database here, good old trusty Wildwood importers, which for this demo is perfectly adequate. I can set my compatibility level to 150, which is 2019, the previous version of SQL Server. And I can use a new feature that we'll demo shortly a little more. I use the new feature, I get back the results I expect. It works exactly the way it should, because in general, compatibility levels don't gatekeep features. I can go back further. I could say make this database into 2008 compatibility level. Why not? And I can run the same query that uses a brand new feature, and it still works. So it's just really important to point out that in general, compatibility level is meant for performance, to ensure that your workload that performs the way you want it to won't break when you up the compatibility level or you can upgrade. So it's really meant to gatekeep performance and ensure that an upgrade doesn't break stuff. And if it does, you can bring it back down, troubleshoot the problems, and bring it back up later. But it's not intended to gatekeep features. And so you'll see most of the features today are available in whatever compatibility level you have, so long as you're on 2022 or you're in Azure. We will jump on back to presentation. I'm going to jump right into features. The rest of this presentation is all about features. I want to talk about functions and T-SQL and new parameters and things. That's the goal of this presentation, and that's what I spend most of our time on. This is a cool new one that I like, that wasn't talked about enough, but I like a lot, and that is distinct from. This is basically solves the challenge of what do you do when you have a column that's nullable or a value that's nullable, and you want to do an equal or not equal to, and you want to deal with null. If you were to write code, or if you're a developer just writing code quickly, you wouldn't think about it. You would simply say, oh, I want all the values that are equal to 5 or not equal to 5. But what about null? We don't always naturally think about null or ANSI nulls. It isn't really a natural thing you consider, but it's important for both performance and for getting the correct results. Ignoring ANSI nulls results in potentially the bad data returned or a poorly performing execution plan. And so these two new features is not distinct from, allow you to do a comparison of values, equal or not equal to, where null can be taken into account. So if you do is distinct from, that is like a not equal to, but null is included. 3 is distinct from null. 3 is different from null. So if you compare them, they're different. Similarly, not distinct from is equal. And null is not equal to 3. Null is equal to null in the terms of this, even though it isn't a value. And 5 is equal to 5. But null is considered a different thing than a different value. A nice thing about this is the optimizer can parse this. It's sargeable. That means that if you use this in your filter clauses and your where clauses, it will be able to use an index and seek the index and get results for you if it makes sense by the optimizer. This wasn't always the case before when you had a whole bunch of is nulls and ors and weird stuff in your code. The nice thing about this on top of that is it cleans your code up and it replaces multiple filters and clauses with one, which is generally just easier to read, easier to understand what you're doing. So what does this look like? Good old back in the day, I might write code like this. I would say, give me a count of sales orders where the picked by person is not 3. I run it. I get back 59,000, whatever. This does not include null. I am incurring an NC null's risk because I didn't really say whether or not I wanted null here. So as a developer, it isn't clear what I was really going for. I clearly wanted not 3, but is null not 3? That's a philosophical question I don't feel like talking about too much today. But if you wanted null or you didn't want null, you may explicitly want to include that in your code so it's obvious what it is that you want. Similarly, I can put the is null in here, right? And by the way, that did use an index seek, even though it was a little funky, it did use an index seek, which is good. But if I do care about null, and I don't want to include it, and I want to be explicit about it, I'll do something like this. Give me the count where the is null, comma 3 isn't 3, and I can do that, and it will explicitly not include null, which is what I want here, and that's good. But now I have an ugly is null around my column, and now it's index scan. Little ugly. It is explicit as to what I'm doing, but it's a little weird, a little clunky, and it's, doesn't perform as well. Similarly, I could say where the picked by person is not 3 and it's not null. So I'm checking explicitly for null separately here. Again, it requires 2 clauses. It gets the seek back. But again, it requires a little more code to get what I want. I had to explicitly say, what do I want to do with null? I can go the opposite direction and say, hey, I want only the 3s and I want the nulls. Okay, I can do that here. Sure. Is null it to 3 and give me all the results. It scans the index, not ideal, and it gets me back what I want. Or I could do this. I could simply say where it's 3 and not null. So, or null. Wow. Where it's 3 or null. Same results back. Forms with a seek, although execution plan is totally complex because it's trying to sort that or out in there. So to do that, it's going to take and create a little mini set of the 3 and null and then pass that in and nested loops it into the seek to get the results. And so you have an execution plan here that didn't require any more I/O, but it certainly was complicated. Here's the new feature, and I like it because it's simple and it's a one-liner and it's easier to read. And there's no question about whether or not you wanted null or not because that's how this thing works. So here I say, same count from, same table, same column, but all I'm saying is distinct from 3. What does that mean? Everything in this column that is not 3. Anything, whatever's not a 3 that includes null. So now I get back everything including nulls, and it gives an index scan here, not because it performed badly, but because that was the right choice because I'm returning most of the table here. That makes sense. Similarly, I can say, give me back a count where it's not distinct from 3, which means only give me the 3s and nothing else. I don't want null. I don't want anything else, just 3. If I do that, I get back exactly all my results that have 3. There's my count. And I can see I got a seek, and it's a very simple plan. So this is a really great feature if you want to explicitly handle null and make sure that everyone knows what you're doing with null. If you have a nullable column, nullable value, this is a great way to handle it. It performs as well as it can perform, better than some of the hacks you can dream up, and it's a very clean one-line thing to do. So I'm a fan of it for that reason. It's new, it's convenient, and it really just helps deal with nulls and the question marks around nulls. Next new feature is something completely different. Approximate percentile. A percentile, disk, and cont are existing features in SQL Server that return median. And if you know anything about median, you know that calculating medians is not cheap. You have to take an entire data set, you have to order it, and then chop it in half and find the middle value or calculate the middle value, depending on which of these you use, and get results. And if you have big data, a sort isn't cheap. If you have millions or billions of rows, sorting all of that data is very expensive. It doesn't matter where you do it, it's expensive. The approximate functions here exist to provide you the way to get a ballpark estimate, a very good estimate, when you don't need a precise value. This sounds weird, like why would you want an approximate? But there are many reasons for it. Very often we're doing calculations that may go up on a dashboard where you're simply looking at a chart and there isn't an exact number. It's not going to have a point there that says 46.342. It's got to simply have some bell curve or some bar chart or something, and you can't really tell it the exact amount. You can guess based on where the bar is. Or you simply just want to understand in general the order of magnitude of a result. Is it 50 or 500? For any scenarios like this where an approximation is good enough, and in this case within a few percent, which is very good, then use this. It'll be faster, use less resources, and that's a good thing for these sorts of things. Faster is what you want, then go for it. What does it look like? Well, in the olden days, if you wanted an exact median, you would do structural. In the olden days, before these functions existing, getting a median was very complicated. You had to have CTEs and order your data set, reverse it, grab the middle value. Crazy. This was introduced later. This gave us the ability to calculate a median as a window function. It's beautiful. I love it. I will never go back from this if I can help it. And if you run this, you get back for each salesperson here, you get back a median for their sales prices. And you can see the numbers here for const versus disk. And just as a quick review, the discrete median basically says, give me the middle value as an actual value from the data set, whereas the continuous says, if for any reason it can't get a middle value because it's an even number, it'll calculate as an average the middle values. So this will provide, the discrete provides you a value in your data set, whereas the continuous provides you a value that's calculated potentially and not in your data set. But they'll be similar regardless, and you get your results back. If I go to the execution plan, out of curiosity, I see a whole lot of stuff here going on because it turns out that calculating a median is complicated, not simple behind the scenes. So, the seeks and scans are what you expect. You can't improve upon that here. It's going to read the data. But everything that happens after that is expensive. Lots of sorting and computations going on. That's not cheap. The new syntax is very similar. It's approximate instead of exact, and I'll run these actually side by side for fun. And we can see that the values you get are very, very similar. In a few cases, they're different. We can see some decimals here, they're different, but they're very, very close. And very, very close in many applications is good enough. We can note by looking at the execution plans, the IO in this case wasn't really changed, but we can see the initial execution plan is far more expensive because it's doing a whole lot of work, whereas the approximate can do a whole lot of shortcutting to get it results. And that shortcutting makes things much faster. There's actually white papers written up on how this kind of thing is done. It's way out of scope for this presentation, but if you're interested in math, and you love math as much as I do, feel free to read up. It could be kind of fun. Otherwise, you can simply tell by looking at the execution plans that, yes, the new functions are far simpler and far faster because we're not taking 240,000 rows, which isn't even big data here, and then crunching it from step to step. So very useful functions, and they do a lot for us. If you need it, great. Next up is a fun one. I like this because it has a lot of uses, but it may not be obvious up front that it's useful. Date trunc will take any date or date time and round it to whatever you want. Round it to the date, round it to the hour, round it to the minute. And it's a truncate, so we're not going to round. It'll just cut off whatever part is after your significant digits you want to truncate out. This used to be hard to do, and it was messy, and it required a lot of T-SQL that made things big and long and complicated. It often didn't perform well either. One note is it maintains your existing data type, which is also nice. So if you have a date time 2, parenthesis 3, whatever you do with date trunc will maintain that. If you have a date, it'll maintain the date. If you have a date time, it'll maintain the date time, which is probably something you want when doing calculations. You're not casting it as a date to kind of clean it up. You're keeping your existing data type. What does this look like? I could take the current date time and I could simply date trunc it to the day. And what that will do is return the year, month, and day, and that's it. Everything after the day has been chopped off and truncated. That's what I did. If I date trunc it down to the minute, I will have my hours and minutes in there as well, but then nothing more, no seconds, no milliseconds, nothing else. I truncate it down to the seconds, I get my seconds, and all those milliseconds are gone. I'm going to plop an index here just for demonstration purposes. I can, if I want, put this in the where clause and do this. And that is a valid piece of T-SQL. I'll note that it won't necessarily perform well. Putting functions in your where clause is not necessarily the ideal case. So if you're filtering, you probably don't want to do this. If you're grabbing your whole data set, day trunking the whole thing doesn't really matter. But you'll note the scans the table because it's got to resolve this whole thing that I did here first before crossing it with my time that I wanted to check it against. If you have the choice, do something like this and don't use date trunc. This is just kind of a performance note. Say, hey, give it to me where it's greater than noon, less than 1 o'clock. I do that. I get back my same results, and I get an index seek instead. It's just a little note here. Date trunc is really awesome, but don't abuse it and put it in a where clause if you don't have to, because it will cause scans and things you don't want to happen. Alternatively, if you're taking a whole data set and chopping it up for analytics anyway, this is a fine way to do it with less T-SQL. For example, I can take my orders here, and I can take it by hour, and then show my value of hours, pick different values in different hours. And here I go. Here is every hour. And note that I'm not rounding to the hour with 24 values from 0 to 23. I'm rounding to the hour for each day and getting back a different bucket for each one. Anything that occurred within each of these hours falls into that bucket. For analytics, this could be really nice. I want to pass back a data set to Power BI to plot on a beautiful dashboard of orders per hour or sales per hour or per minute, per second, whatever. This can be a nice way to do it. You can do it in Power BI as well, but if you have mountains of data here, you may not want to pass a mountain of data there first. That's really up to you as a preference, but it's an option that's available. The way it used to happen in the olden days is I'd be forced to do something kind of like this, where I'd have to group by the date and the hour and the minute and the second and so on. And you can do this, and it was just more complicated. That's all. Your execution plan was more complicated, but that's really about it. I like simpler code personally, and if I can make changes to simplify my code and make it easier to read and have less lines of T-SQL, less characters of T-SQL, great. Shorter and easier to read is better in general for me, on it's performing as well. Are there any questions in the chat yet, by the way, or anything to talk about yet?
No, there are no questions, but if we stop, I will, if I may, just say a few sentences. One, just to emphasize regarding null. Null is not a value. This is why using equal null is always confusing, and it's a different way it's implement in different languages. It's not the same. So this is why the new feature is very useful. Regarding date trunc, it's very useful, for example, for column store index. If you can round the date to a specific interval, then you can use it for column store index.
Good points there. And yeah, I 100% will just, jump on the null thing. Null isn't a value. We often call it a value colloquially, but it's not a value. It's the absence of things. If you ask me my age and I say null, that means that somebody doesn't know my age. It's unknown. It's not provided. And people define it differently, but null is definitely not a value. It's a wonderful call out. Let's keep going. We have lots more stuff to talk about. This next set of new functions are, if you need them, they'll be very, very useful. If you don't need them, you may just simply kind of drowse off for the next 2 minutes. But bit manipulation is one of those things you may, if you have bit masks or bit arrays or configuration settings, they're all bit hashed. This is a great way to very efficiently manipulate numbers and adjust them bitwise. And these didn't exist before. So this always involved like doing math and then converting, and that wasn't always very fun. This does a lot of work for us. If you need it, it's great. That's the easiest way to say for this sort of thing is if you need it, it's great. So we're going to talk about here in binary. This next section is in binary. Imagine binary ones and zeros in your mind. That's everything stored anyway, but we're going to talk about ones and zeros. So imagine number 16. 16 is 1 followed by 4 zeros. I can left shift and right shift. And all a shift does is multiply or divide. So if I left shift, what is that doing? It's adding a 0 in the end. That's all. It's multiplying by 2. So if I left shift by 1 time, So multiply by 2. 16 becomes 32. If I left shift by 2, then I'm multiplying by 4, I get 64, and so on and so forth. Similarly, right shift is dividing. If I right shift, I'm chopping off bits in the end and dividing by 2. If I write this, then 16 divided by 2 is 8. Divided by 4, it's 4. If I divide by enough that I get past 1, then it simply goes to 0. So if I right shift the number into oblivion and nothing is left, you just get 0. It doesn't go to null. It doesn't go to -1 or -2 billion or something like that. It just goes to 0. And so just keep in mind when you're using this, if you left shift past the scope of your data type, you'll throw an error message. So if I left shift by like 50, you're going to cause trouble. And if you right shift all the way past your decimal, you'll just end up with 0. Just keep that in mind when using these. There are limits. The limits are your data types. And if you break them, you get what you pay for, I guess, right? Similarly, you can count bits. So bit count is just as simple as it says. It will take the number of binary bits and count them, all the ones. It'll count the ones. So for 16, I get back 1 because there's 1, 1 in 16, 1 followed by 4 zeros. 15 has 4 bits, 1, 1, 1, 1. Bit count 1, you get 1. Bit count 0, you get 0. And that's all. Great way to find out how many ones are in a number. Is it odd or even? Things like that. You can get it very quickly this way. Do be aware negative numbers. If you put negative numbers into this, they're not what you think they are. -2 is not like a 1, 0. It's actually kind of like an inverted number. And so if you do a bit count on -2, you get 31. A bit count to -1 gives you 32. This is kind of just like weird. Why is it doing this? It's inverting your number. It's rolling over inverting. It's not actually a negative version of the number I just gave you. So if you actually want to get a literal bit count of a -2 where it's 2 with a negative sign in front of it, then just cast it as a small int, or absolute value it if you need to as well, because the casting it will only bring you down to the data type. So if you cast a small int, well, I've constrained it more. I'm only rolling over into the range of small int, which is 15 bits instead of 16 bits instead of 32 bits. Still, this may not be what you want. If you really just want a literal count of bits, put the absolute value in and you're good. And so now, the absolute value of -7, 7, 3 bits, done. It's just a little warning note there. Negative numbers behave funny. If you can get negative numbers into your results, just beware because they may not be what you want. Some more things you can do. Get bit will get you the current value of a bit inside of a number. 53 is 110101. I can get each bit one by one and see how that works. So I can get the 5th bit. So the larger numbers are on the left, most significant bits. Smallest numbers are on the right. Your 0th bit is your final bit. Similarly, I can do it for a hex number if I want. It turns out that 53 is hex 35. Don't think about that too much, please. It's not worth it. But there you go. You can throw in your hex value and get back the same numbers that you got before with the binary numbers. Set bit does exactly what it says. It'll take a bit and make it 1. So for example, I can set the 5th bit of 53 to 1. If I do it, nothing happens. It's already 1. I can set it to 0 though. If I put a 0 here, that will change a bit from 1 to 0 or whatever it is to 0. It'll keep 0 as 0. And if I do that, I'm subtracting 32 and I go 53 to 21. So if you just put set bit like this, you set it to a 1. If you add the additional parameter of a 0, you set it to 0. You can confirm it by simply doing a get bit of a set bit. But this is a way to change a single bit in a string of binary muck to whatever you want. So you can get it, you can set it. It's pretty straightforward. So I won't spend any more time on the binary math, but if you use it, these are great functions. If you don't use it,
there is a question regarding this or request, and I think it's very important. Can you give some real scenario cases for using those functions? And if you want, I will just answer it.
Sure. I think that some of the more common uses would be either you're working in binary or hex, so you're storing numbers as binary or hex numbers, in which case this will be the easiest way to do math. The more common scenario I find is that people often encode data into bitmaps or bit arrays. So they'll have some configuration settings, they'll store them in binary or hex, and they'll grab bits out of that. Now, I don't necessarily advocate that. I think it's a nice way to save storage, but it can be complicated. But if you do happen to store data as like a bitmap, where, you know, the first bit is this configuration setting, the second bit is different setting, the third is different. And SQL Server does that, actually. There are a few places in SQL Server where configuration settings are stored like that. If you have to deal with that, though, this can be a nice way to quickly get bit, grab a certain setting, or tell me how many settings are flipped to 1, or things like that. Those are probably the most common scenarios. There could probably be others I could dream up if you want. But you may or may not have those scenarios in your world, and if you don't and you have no need for it, that's also cool. I wouldn't go looking for a use for this. Features are not created to find solutions to problems that don't exist. They're there to solve real problems. If you don't need it, no problem.
This is the most common scenario, and I will give you a tip about unknown scenario, which can save you a lot of performance. Let's say that you want to do, this is my tip, it's not documented. Let's say that you want to change a number, decimal number, from plus to minus. For example, you have 10.5 and you want to change it to minus 10.5. If you know about the internals and how this is stored behind the skin, so you know that actually a decimal number stored the minus as a separate from the number itself, which is stored like integer. So what you can do, you can get a much better performance if you do not calculate. You don't need any math. You only need to go and set the bit of this specific place, and then you change the number from plus to minus and vice versa.
Add a comment when you do that too, so people know what the heck you're doing. But yes, that is very true. And if you want to eke out perfect performance, that is very true and very interesting too. Thank you. I like random tidbits. They're fun. This next T-SQL thing here is more of a maintenance aspect, but it's worthwhile because you have mountainous indexes and you do have to rebuild and manage them through index maintenance. You may or may not. But if you do, you can have resumables. And resumables are nice because they allow you to pause things that are in progress and not lose your progress. So if you have big size data structures and you want to rebuild them, and you get stuck in the middle and have to stop, a reorg can just continue later. But the rebuild will, if you just normally stop it, it's done. I'm going to try to demo this, and hopefully I can be fast enough. So I'm going to quickly build a table and put some data into it. So we're going to create a table. We're going to give it a resumable index. So there is an option you have to put on there. I'm going to say create my PK on here, resumable on, max duration 15, which means that if I hit 15 minutes, which I'm not going to do in this demo because you'll be bored to tears, but if you hit 15 minutes, it'll stop, but it'll pause. It won't just stop, it'll pause. You can then resume it later. I'm going to put a bunch of data in here, but not too much because our time is valuable. And then I'm going to go over to this window here, and I'm going to rebuild the index resumable on. And then let's say your maintenance process says, uh-oh, we're hitting prime time, people are going to be using your data, stop rebuilding indexes, I want all those resources for our users. I'll come along and I'll pause it. Let's see how fast I can be. F5, F5. Aha, that was good. So this got disconnected immediately, so I began rebuilding the index, and then I paused it. In pausing it, what it actually does is it kills my session. So bam, this window is toast. Not connected anymore, it's disconnected. But it did rebuild some of the index. We'll get rid of that. I can now go to a brand new DMV and see, hey, index resumable operations. I can go to the system view and look and see, all right, here's information on what I just did. I was rebuilding this index here. Here's the exact text of what I was doing. I'm caught in the act. You can't, I can't get out of this one. Here's some information about it. Here's when it started. Here's when it paused. Here's the percent complete it was. So I caught it with good 78% to go, 76% to go. Not bad. And there's the page count. And so whenever I'm ready, my maintenance process, or me, or whatever, can go in here and hit resume. And when it's done, I can now go back and notice I'm putting parameters here. I just said resume. It already has all the parameters of that alter index operation from before. And now this view is empty. And so the resumable operation completed, and life can go on. This is really useful if you have big tables in big databases, and you start rebuilding something and it goes on for a long time. You don't want to lose your progress. And so this ensures your progress isn't lost, and you don't waste time and resources, because time and resources are money. And sanity too. So a nice point to have here. This exists. If you've never used it before, it's pretty cool. So we'll get rid of our test table. I'm going to move on to a set of new functions that I really like that are completely unrelated, but I like them enough that I made a lightning talk for them. So we're going to dive right in. Greatest and least. These have been sorely missed by SQL Server for the past forever years. Like, ever since it came out, I wish this had always been here. And we finally have it. Greatest and least. What does this do? This is not min or max. This is very different. It's a row, it's a row-based function. So in a given row, when you use these functions, you can pass in any number of columns or values, and it'll give you the largest or smallest of those values. You can pass in as many as you want, up to 254, though if you put 254 values inside of this, congratulations, I guess. I don't know. But these can be columns, they can be expressions, they can be parameters, values, scalars, whatevers. You can aggregate if you want over this. These in and of themselves, these are not aggregate functions. When you use them, they will, just like min and max and all of them, they will implicitly convert to the data type of the highest precedence. So if you have 5 different values and they're all different data types, you want to get the greatest or least, it will choose the order, the data type of highest precedence. You're about to ask, what does that mean? I'll send you to the Microsoft Docs and say, look up conversion order of precedence in SQL Server, and there's a big long list from highest to lowest order of precedence, and you can read it. And honestly, it'll do a better job than I can because I don't feel like listing them all out right now. We don't have time for that. I loved it so much I made a lightning talk about it, so I will share this whole slide deck and demos later. And included in here is a link to that. It was a 10-minute talk on just this, greatest and least, that was it. These are really, really useful because in the olden days before this existing, the T-SQL to do this was big and messy and hard to read and confusing and easy to make mistakes too. So here's how the new stuff looks. Let's say I want to get a last modified time. This is actually a pretty common use case for using greatest or least. I want a last modified time, or I want a first modified date. To calculate that, if I don't have a column for that already, I may say, all right, take these 4 values and give me the greatest of them, the last modified time. Or maybe I'll say, grab these 1, 2, 3, 4, 5, 6 values here and get the least of them, the earliest one, to get a first modified date. This is really convenient. In a single line, I can get from as many values as I want the smallest value, or the greatest value. If I run it, I get back my results. And again, this only costs as much as my data would cost me to get. In this case, to scan, because I need most of the table anyway, the filter wasn't that big, but this won't cost me anything beyond my filter. So this is really, really clean, slick, and nice. It really, really is. What did this used to look like? This used to look like a big case statement. People would say something like, all right, case, when this is greater than this, then this. When this is greater than this, then this. When this is greater than this, then this. When this is greater than this, then this, and so on and so forth. And that was how you used to do this. There are other ways to get this. And if you're like in Power BI or in some graphical solution, other ways to do it. But in T-SQL, your ability to calculate this was messy, and it was hard. It involved case statements that were not only messy, but because they were big and long and messy, it was very easy to make mistakes. So if you've never used this before, you will find use for this. As soon as this was announced and became official, I began flagging my code with comments to find places where I would use this. So as soon as it became available, I would drop this in and get rid of all the old case statements of the code. So very, very useful, many applications, and it will take big, messy code and make it small and compact and easy to read. This is very, very easy to read compared to the horrible things that are described to you. So I highly recommend this when you have it available. All right. This is not a new function, but it has a new thing that was added to it that is very useful. String split is what it says it is, and before it existed, it was very hard to split strings. It was a hassle. You had to do all kinds of XML parsing or iterating or weird stuff like that. String split was a great function. It allowed you to inline take a string and split it by whatever delimiter you wanted. But there was something missing, and that was order. And while the order was generally what it came back as what you provided, that order wasn't really guaranteed by anything. There's no way to really manage the order afterwards. So what was added, and this actually requires compatibility level 130 plus, not really a huge deal because you use string split, But what this adds is a new parameter called the ordinal, which is basically just a number. It's a number that can be used to order your results. So basically, kind of like a row number over, it gives you a number list alongside your results if you want them to, and you can perform math on it. You can aggregate it, filter it, do whatever you want. It's a really nice thing to have when you want it. And I'll show you an example of how that works. So if you want a string split something like this, a string full of stuff separated by commas, I can do that, and I get back my 7 values, just like that. You can split by anything you want. You can do it by space, new line, semicolon, dash, whatever. It doesn't matter what you split it by, and you get back a value. It's a great function. It's useful. We've all probably either used it or probably have a use for it in our world of SQL. The ordinal essentially returns, and the ordinal is an added parameter you must supply to use. I have to actually add a brand new parameter, in this case a 1 here, to indicate I want to use it. So the 1 says use the ordinal. When I do that, I get back value and ordinal. If I don't do it, I get just my value back. If I run this, I get back my same list as earlier, spliced by comma, but, separated by comma, delimited. But now the data comes back in the order I provided it, and I have a row number here. So I have a number 1 to 7 that I can do things with. This is really useful. It's worth noting that you can't put a 0 here. Putting a 0 there will not mean don't use ordinal or use ordinal or whatever. It's just not supplied. You put a 1 there or you put nothing there. You get invalid column name, syntax, whatever. You just can't do that. So 1 is the only really useful value to put there. Anything else is confusing or error prone. Similarly, if I don't put a value there, ordinal won't exist. So if I do this, I also get an error message because I didn't supply a 1 there. Therefore, ordinal wasn't returned. And this is really to support backward compatibility. If you have old code that does not have ordinal, it will just keep working the way it always did. And that's good. It'll only add this new thing in if you put a 1 there. You can do fun things with ordinal. You can do anything you want. You can group by it. You can filter by it. You can do math on it. Nothing's stopping you. It's just a data set being returned. So if I want to get every 3rd value, I can do this. You can multiply it, divide it, math it however you want. It doesn't matter. So this is basically a number being returned to provide order to your data, to allow you to manipulate it and manage it and do whatever you want with it. So you don't have to actually provide a row number anymore. It'll do it for you. So very, very useful if the order of your data matters, if grabbing a slice of your data matters, or if simply filtering on certain values matters. Like give me the first one, the actual first one. You can do that now, or the 2nd or the 3rd or the 4th, or every other one, or the last. You can get the last as well. I can get a max ordinal and get it that way. So a lot of flexibility here. It's a new feature. It's optional, but it's very useful. Any comments or questions in the chat or anything you might have?
There were a few questions. We already answered them. There was a question regarding greatest and list and how it behaves with nulls. So I gave the answer in the chat and the link. And there was a question regarding do we have to use the same format if we are using dates? So the answer is that there isn't a different format for dates. What usually you use is string, which represent a text, a date, and then SQL Server implicitly convert it to date. If you are using dates, as I said, there is only one format of the way that SQL Server stores dates, so this is not relevant.
All right, Ronan on top of the chat. Very nice. Cool. Thank you. Let's jump back in and Alt-Tab about 100 times because I overshot. There we go. The next one is going to sound very, very similar to date trunk, but it is different, and I'll demonstrate why, because the difference is important. It's possible to misuse this if the difference isn't obvious. But basically what date bucket does is it will bucketize your data into almost like a grouping or a hash table. So it's going to basically return a rounded date time based on whatever date part increment you provided. And so if you want to group, values like this, and this actually makes a lot of sense. We very often will have scenarios in the world where we want to say, all right, I want to take my data and plop it into, group it by every 2 hours. So every 2 hours, I want a bucket of data that includes data that was within that 2-hour span, or 4 hours, or 8 hours, or 12 hours, or a day, or a minute. Whatever it is, you can bucketize your data into groupings based on whatever parameters you have. And the beauty of this is that it's very flexible. You can provide it whatever information you want. There's an origin parameter that also handles the classic problem of, well, when does it start? So if you were to say, date bucket my data into every 4-hour buckets, well, when does the 4 hours start? Does it start at midnight? Does it start at 1 a.m., 2 a.m., noon? When does it start? And the answer is, if you don't like what the default is, you can specify it. The default is 1/1900 at midnight, which is pretty much going to do what you intuitively think it would be. You're starting at midnight. But if you bucketize by larger amounts, like 3 months, 4 months, 6 months, whatever, years may begin to matter on this as well. For fiscal analysis, it can be very useful as well, because fiscal quarters and fiscal years don't often bucketize according to what SQL Server provides. I may say, hey, give me my quarterly information out of SQL Server, to which it'll say, oh, a quarter. Well, January to March is 1 quarter, April to June is a quarter, so on and so forth. But if you're on different fiscal calendars, a quarter may begin in November 1st, or a different time of year, or maybe even November 15th, for example. So for fiscal data and management, this can be extremely useful as well. How does this look in the world of demos? Because I love demos. Well, we'll take a date and time that I predicted I would be in this presentation, and I was off by a little, but that's fine. I was just guessing wildly. So I take this date time here from today. It has all the incremental, all the components, hours, minutes, seconds, milliseconds, and I say bucketize it by hour. So it plops it into the noon bucket. If I bucketize it by 2 hours, it plops it in the noon bucket. If I bucketize it by 8 hours, it'll plop me back into the 8 a.m. bucket. If I bucketize it by minute, it'll say, okay, you're in the 12:35 bucket on 5/25/2023. And then if I bucketize it by day, it's kind of like date part day. And that's great. But again, I can get more specific if I want to. Similarly, I can bucket by week or month. There's really no limit here. If you're interested in taking, this is actually a very common problem we do. Like, I want to take my data and bucketize it bi-weekly. Maybe I manage payroll bi-weekly, or I have transactions I process weekly or bi-weekly. Being able to bucketize it and customize it is very useful. Similarly, you can do it by like other increments as well. So I can see here, let me find one where they're different. Can I find where they're different? Yes, so I can see here that, the date is 10/2. That would fall into the 1-week bucket of 9/30, or the 2-week bucket of 9/23, a 1-month bucket of 10/1. And so however you want to bucketize your data, you can. And then if for whatever reason the numbers you see here aren't quite configured the way you want, let's say, for example, you wanted your 2-week period to start on 9/30. This is a very common problem with payroll, right? You do bi-weekly, but when does your bi-weekly payroll begin? Is it this Friday or next Friday? Well, ask HR, I don't know, but whatever it is, you as the person in charge of the data want to make sure you return the right bucket, and you can configure that here. So to do that, you add in a different parameter called origin. And so in this case, I provide different origins to kind of demo how this looks. For example, let's say I want to bucketize by hour. Every 8 hours, I want 8-hour buckets. Well, when does the 8-hour period begin? It could be a work day, which for different people in different places could be different, right? It could be 9 to 5, it could be 8 to 4, it could be 7 to 2. But what is it going to look like? Well, the answer is going to be shown like this. So if I take 8-hour buckets, and the default origin here, 1/1 at midnight, is kind of like the default SQL Server has. It was 1900, but close to default. And I get the 8 a.m. bucket, which makes sense. If I adjust the bucket to begin at 1 a.m., I can see now this bucket is 9 a.m. So I'll have 1 a.m., 9 a.m., I'll have 5 p.m., and so on. If I change the bucket to the origin to 2, then now it'll be 10 a.m., and if I change to 3, it'll be 11, and so on. So by adjusting the origin parameter, which is optional, I can tell it where to begin the buckets and produce that bi-weekly payroll, or every 2-hour bucket of data, or every 4 hours, 8-hour workday, and so on and so forth. So this is a very useful way to customize how your data is bucketized. And again, this is why this is very different from date trunk, because you're not simply lopping off the end of it. You can customize to really do whatever you want it to do to match your data needs. All right. Whenever I demo this, the first thing somebody asks is, isn't this like a sequence? And the answer is sort of. Generate series is new, and the purpose of this function is to solve the challenge of tally tables. And so we have for years and years and years had this need to, on the fly, generate a set of numbers or decimals or something that I can then join to later. Like I want to have a tally table to join to a number something. And before this, I was forced to use a CTE or a tally table or a structure of some sort that I create in a temp table to give myself the ability to do this. This does it for me, though, and it does it without the need for any physical structures that go into tempdb or onto storage somewhere. And the beauty of that is no I/O is required. When I use generate series, it doesn't require any logical reads because it's being stored in memory, not on tempdb or elsewhere. It requires a new compatibility level to the performance needs of that, but it is very, very cool. A sequence is like an actual structure in SQL Server. You define it and you maintain it, and it's like a physical thing that you're maintaining for use by the server or a database. Generate series is not really meant to be that large of a scope. It's not meant to be permanent. It's meant to be used on the fly as a way to get numbers. How does that look? It looks like this. Let's say I want to generate a series, and the syntax is pretty simple. Start at 1, end at 17, increment by 1. If I do that, I get back 17 values, just like that. So I'm just generating a series, and I can interjoin this, I can left join it to other things. This is really just returning a table, a metaphorical table, but it's a table, and then I can just join to other things and use it. So you can take stuff and left join it to this to get all your values. So for example, if you need to take all the hours of the day, 24 hours, and then join them to data you bucketize to hour, you don't have to take and create a tally table of 24 in a CTE or whatever. You can simply generate series from 1 to 24, well, 0 to 23, I guess, and then bucketize it and join it and be done without the need to have a tally table. Similarly, there's no limits to what the values can be. I can put in here a bigger number, and it'll increment by 1,000,000. That's fine. It's not care at all how much I do it by. Do note this is an int, and if I put in integers and I get out something bigger than an int, you might get an error message. Just keep that in mind, that if you cross data type boundaries, because you're passing in actual like parameters with data types, that can be an issue, worth keeping in mind. But again, the start, the end, and the increment can be whatever you want them to be. There's no limits here. I can start at 100 if I want to and keep going. Kind of like compatibility levels, I can do this too. And then, cool. So I can start and end it whatever I want, increment by whatever I want. And I can even use decimals too. For example, if I want to do percentiles, percentages, or increment by numbers that are not a whole number, that's fine. You know, 100% do that, and it's totally cool. I can start at 0, I can end at 1, and I can increment by 0.01. So if I care about percentiles or percentages, I can left join into this and get all the possible values from 0 to 100. That might be important. So again, you can use whole numbers, you can use decimals, you can really use any kind of numeric thing you have that can be incremented effectively. As long as you can add numbers to it, it's okay. So use your imagination, lots of ways to do this. So very cool function is not the same as a sequence. It's not the same purpose, the same implementation, or the same reason for existing. But this is very useful for what it attempts to solve, which is the tally tables that take us into a weird world of code that we don't want to deal with. So now I am lost somewhere. There we go. All right, back to the presentation. I'm not going to demo these because not a lot of people use them. But if you do JSON in SQL Server and you rely upon it and it's important to you, these will be useful to you, I promise. I used to have demos on these and everyone just said they didn't use it, but some people do. There's always 1 in 20 that use it. So if you happen to use JSON in SQL Server, grab the link on the bottom here, look it up. These are not complicated, but if you use JSON a lot, you'll fully understand what they do and how they work. If you don't use JSON, this is like gobbledygook. But again, extremely useful if you use JSON. It will give you the validity of your statements. Is there a path located within your JSON object? You can grab an object from inside of it. You can build an array out of it and do a lot of cool things. So this is very useful if you use it. And I put the link here in case you do. You can go there and things are explained pretty well there. But no demos because most people don't use this. And therefore, I'm just kind of keep going. So we're kind of getting near the end here of things before we go to Q&A. This is kind of a cool one. Window is a new feature added that allows you to simplify and shorten your code. The purpose of this is when you have window functions that are getting big and ugly because they have, partition, order by, row number, row over preceding, following, lots and lots of syntax, it can get long and hard to read. And the purpose of this is you define your window once and then use it over and over and over. The purpose of this is not to improve performance. It doesn't. It's not intended to make things, better performing. It's not meant to make the optimizer more efficient. All this is meant to do is make your code cleaner and easier to read. It also, by doing that, avoids typos. If you have the same window 10 times, it's big and complicated, and you make a change to one of them and you want to make a change to all of them, you've got to go in there and change all of them. It's very easy to make a mistake, have a typo, and have them be different. You won't want that. This requires compatibility 160 or above to use, but it's a really nice feature. And it's worth kind of looking at how it plays out in SQL Server. So this is a very simple example. I could have made this much more complicated if I wanted to. Didn't really feel like it. But here is a classic query where I'm saying, give me a row number, give me a count, give me a max, and I'm partitioning by the same thing. So for each customer, give me a number, give me a count, give me a max. Order by salesperson, person ID, done. And I do this, and I get back my values, and that's great. And it works. Most recent order date, a row count total, the row num, and I get it from each salesperson. Awesome. Done. By each customer. Done. Perfect. Just what I wanted. But what ends up happening over time is if I have more and more of these window functions, my code gets messier and messier. And occasionally your code's going to change. Where you're going to say, order by one additional column, or partition by one more column, or add some additional following and preceding information to adjust the frame. And as you do that to adjust your windows, it's easy to make mistakes. So what you can do here is I can create the window and define it down here. It's a new part of a SQL Server query. So the query has a new part at the end to define a window. This goes to the end of your query. And I would say, here's my window. I name it customer window. Then I define it. And the definition here that you see is exactly what I had up here before, over and over and over repeated. That's it. No difference. It's exactly the same, but now I don't have to repeat it. So now up here, I simply say row number over customer window, count over customer window, max over customer window. And so the beauty of this is now I've made my code smaller and simpler. Now if I ever need to update the window, I can do it in one place, right here, and it'll apply to all the window functions that use this window. So this is really convenient, especially if your windows get complicated and you have lots of interesting, I want a sliding average that goes over 10 rows before and after, that kind of thing. If you have a running average or something like that where you have big complicated syntax here, this guarantees that you can keep it maintained in one place and then reuse it as much as you want above. So very cool, very convenient. Again, it's not meant to improve performance. This is intended to, and again, it executes the exact same way. There's no difference in results at all. But you get back what you want with less T-SQL and less chance to make typographical errors when you're coding. All right. The subject of window functions. There are some new window functions with additional functionality added in. So these are not new in of themselves. First value and last value provide exactly what they say. If you have a window function and you have a window, it'll give you the first and the last value. This is not the same as the min or the max. The min gives you the smallest value. The max gives you the maximum value. First and last value just happen to give you the first and last value based on your order by. And so it may not be a min or a max. It'll be the first based on your order by, or the last based on your order by. This could be very useful. So the new features added are how to handle null. As we discussed earlier, multiple times, null is not a value. Null is not a number. Null is not 0 or -1 or a blank or whatever. Null is a thing, it's an idea, it's a non-existence or whatever you define it as. And we can now define in line how we handle null. And this is important because there was no real way of handling it before. So let's say I had a function like this. I'm using the new Windows syntax for fun. Let's say I had this query here with first and last value in it. And I go ahead and I run it. And what I note is that I get back my first and last value, which may or may not be equal to the most recent order date, it doesn't really matter, but I get back my first and last value within a window, and I look through my list here, and I get them all back. And that's cool, but what if there's nulls involved? What happens then? Well, the question is, how do I want to deal with them? Do I want to include them or not? The default is to respect nulls now instead of ignore nulls, and that's an important differentiation. If you have a first value, should that include null or not include null? And there's a big difference, and you may care about that difference. So now I've taken here, and I have more stuff in here. So I can see after my maximum, I have first and last order date. I simply have them with no details. So they respect nulls, and there's no problem here. In this case, there are no nulls. But what about other columns? Let's say I do the first value of this column, and I don't provide any detail. Well, null is the first value. Okay, cool, I got back null. But null may not be what I want because null isn't a value. I actually said, literally, first value, and I got back null. So to some people, that will make the hair on the back of your neck stand up because null isn't a value. So if you respect nulls, meaning you want them there, it will keep them. So if you do first value respect nulls, your nulls will remain. So a null is considered a value, even though it isn't really a value. And there you go. So this and this are the same because that's the default to respect nulls. But let's say I don't want null. Let's say that to me null is not a value. I want the first non-null value, or the last non-null value in a window. To do that, I would say ignore nulls. And this last column shows what that looks like. And I can see here now that I now have values here. Now you notice it's still null occasionally. If the only value for this is null, I get back null because it's life. I can't make up a value. But if there is a value, it will now grab the first non-null value and return that. So the default is respect nulls, which is the old behavior. Whatever the first thing that's there, it gives back no matter what it is, even null. If you do ignore nulls, it will return the first non-null value if there's one available. So depending on what you're doing, this may be a very great way to get back the values you want without having another case statement and check where not null and stuff like that. You can now not have to worry about that. So if you want the first or last value back, and null is not a value, and you want the first non-null value back, this is how you get it. A little bit more left. More functionality has been added to these functions as well. We talk about trim, ltrim, rtrim. Some new keywords were added, leading, trailing, and both, which allow you to customize a bit more how trim works. In some ways, it's really behaving kind of like how ltrim and rtrim work, but you get more functionality now out of it. It allows you to kind of just fully trim however you want to with one statement. It requires a new compatibility level to work, but it's a new argument that was added that is worth pointing out now. So I'm going to make up a string here. Yeah, I call it a string in a string face. And I'm going to do all various things with it to see what happens. So I put my name Edward in the middle of a string with some A's on the end, some junk. It could be periods, semicolons, spaces, whatever. And if I were to simply say trim the A's out, I trim the A's out. If I trim the leading A's out, it trims only the leading A's out. So if I do that, it'll remove the leading A's but leave the rest in place. So it finds what it wants to trim until it hits a non-A and it trims it out. Similarly, trim the trailing A's out does the opposite. It pulls the A's off the end and slices them out until I hit a non-A, and I'm done. Trim both is kind of the default behavior already. Trims A's off the beginning, trims A's off the end, done. And similarly, I can do other things like trim sections of letters off, trim this off, trim A, D, E, or W out. Won't leave me with much, but I can do that. Or remove the trailing A's, D's, E's, and W's, just a list of letters. Or do both, not left with much. The benefit of this really, in my mind, is it not only does it let you trim leading and trailing more explicitly, you define and you really document here in your trim statement what it is you're doing. There's no question mark in anybody's mind what you're doing when you write these statements here. I know exactly what I'm trying to do. There's no question as to what it means. Whereas when you start cascading R trims and L trims with all kinds of parameters, it's kind of complicated. This really explicitly says, I want to remove leading, trailing, or both of whatever characters I want. So this is useful. If you rely on string manipulation a lot, this is probably going to be very useful for you. If you don't, maybe no biggie. But I do like it because it documents what you're doing better. And I think that if you can document your code better, make it easier to read without making it perform worse or anything like that, do it. Definitely do it. Make the life of the future developer who comes after you easier and happier. They'll thank you for it. So that's the last T-SQL functionality I want to demo today, were the new pieces of trim. Does anybody have any questions before I kind of run into the conclusion and wrap up and see if we have anything left for me before we are done and head back to our days?
No, we are good to go.
Cool. All right, deep breath. That was a lot. The real lesson here to be learned is that SQL Server 2022, like every version, and in some cases subversions, has a lot of new useful T-SQL syntax, and a lot of it didn't get headlines. A lot of it was like, hey, it's there, done, and we all forgot about it. But many of these things can be game changers for you in terms of making your code cleaner, easier to read, and perform better. And so if you know places you can use this, consider using it. Upgrade, test, use this code. This is a chance to make things better. And there's no cost to you. The cost is just replacing old code with new code. Or writing new code in better ways. So if you can use it, use it. These are great functions, great features, great parameters that have been added into existing functionality. Use it. They're wonderful. I like many of these. Greatest and least, first value, last value, the adjustments made there generate. See, I'm already using those in production environments, and I love them, and I will not stop using them. So hopefully you feel the same way. With that, I will simply just say there'll be more of this in the future. At some points in the future, things will appear in Azure or in a new version of SQL Server. I'll be chatting about them soon, and we'll have this conversation again. But until then, feel free to contact me, look me up on LinkedIn, connect with me, and if you have any thoughts for me in the future about any of this or more, feel free to share. That is everything I have to wrap up this lunchtime session today. Lunch if you're here where I am, not lunch elsewhere. So back to you, Ronan. What do you have?
Thanks a lot. Let me just share my screen. And thank you again. Okay, so first of all, let me switch this. And now I can thank you again, Edward, for a great session. And I want to thank everyone who joined us today. I gave you a riddle on the chat. Check it. You will get a strange result. Try to explain the result that you get. And don't forget to follow us, and we will meet next week and register to the Future Data Driven Summit. That's it. Thanks a lot.
Thank you very much for having me today.
I'm closing the session. Bye-bye, Ed. Bye,
See you
everyone.
later. Take care. Bye.